encouraging or advising anyone to modify their firearms. This is not a tutorial. This is for entertainment purposes only. What's up, everyone? I threw in the standard cover my own ass disclaimer, but this is indeed a tutorial. I've gotten multiple comments asking how I clean up and polish parts. Some people want to see the whole process, start to finish, so that's what I'm doing. I'm not encouraging anyone to do this. If you are not comfortable attempting any of what I show here, then don't. If you're new to it, practice on some scrap metal or old firearm parts you have laying around first. Since this is the engineer's armory, I can't just make a video showing me polishing some shit. No. I gotta go into the theory, the math, the physics. We gotta understand why we're doing what we're doing, man. If you do just want to see me polishing some shit, timestamps are provided, as always, so you can skip to that. I'm going to be showing polishing procedures for different surface shapes first, to give you the most widely applicable and general procedures. They will, of course, all be gun parts, and I will mention some procedures related to specific parts. I will talk a little bit about how coating can affect polishing. I will show some specific procedures like slide lapping, feed ramp polishing, and polishing, hammer hooks and sear faces and things like that. Let's get into it. Why do we even want to polish or smooth up components?
Why?
The short answer is to reduce friction. What will reducing friction do for us? It will decrease resistance to movement and wasted energy. Great. What does that mean in the context of a firearm? It can make the firearm cycle and operate more smoothly. This may increase reliability. It will reduce wear between components. It makes it easier to tune other components like recoil springs by making the effects of those changes more obvious. If we take out excess friction from surfaces interacting with each other, it allows the energy of the cartridge being fired to do the work we really care about, which is making the gun operate, cycling the action, and being ready to fire the next shot. Subjectively, it's just going to make the gun feel nicer. We should talk about friction and how it affects the movement of an object. Friction force comes from a frictional coefficient between two surfaces multiplied by the normal force. Mu is a Greek symbol for the frictional coefficient. There are tables like this one of frictional coefficient values that have been determined empirically. The normal force is a force acting perpendicular or normal to the sliding surface. In the most basic case of this box sitting on the ground, it would be considered the box's weight. Mr. Newton let us know that force equals mass times acceleration. You apply a force to an object like this box, it will accelerate at a rate proportional to the force applied and inversely proportional to its mass. You input more force, you get more acceleration if the mass stays the same. You increase the mass, you get less acceleration if the force stays the same. But this just isn't a pushing or pulling force. No, this is the sum of all the forces acting on this box. Let's say we're pushing the box this way with force F. Well, our dynamic friction force is going to be opposing that movement. Let's say these are the only two forces acting on this object, neglect wind resistance and shit. The sum of these forces equals mass times acceleration, which is our pushing force minus our friction force. And our friction force is the frictional coefficient multiplied by our normal force, or the weight of the box. If the sum of these forces is 0, there will be no acceleration, meaning the box will be moving at a constant velocity. If the sum of these forces is greater than 0, the box will be accelerating. If the sum of the forces is less than 0, decelerating. If we reduce this friction force, the input force can act more efficiently on the box, or you can input less force and get the same movement results. The way to reduce this friction force is either by reducing the normal force, or in this case, the weight of the box, or this frictional coefficient mu. How does surface roughness affect friction? Let's look at a representation of microscopic views of two surfaces. All these little projections and grooves will be catching on each other as the two surfaces slide past each other. This is where our dynamic friction comes from. That is the friction associated with a moving body or object. Static friction deals with the friction force that must be overcome to move an object from rest. Polishing creates a smoother surface, meaning there are less and or smaller projections on the surface. Less projections or shallower features to get hung up on means less friction. This will reduce our frictional coefficient mu in our friction force equation. What if we added oil? Well, it can actually create a slippery little layer between our two surfaces that can reduce the number of projections that contact each other. This will further reduce friction, and it's why we oil our fucking guns. What about parts wear? The bigger and rougher the projections, the more they will wear down each other because larger chunks are likely to come off and larger projections will shave off larger chunks. Of course, there are ways to quantify and measure surface finish or surface roughness. As an engineer, I have to be aware of the surface finish on parts I design. Maybe if a part interacts with a soft seal, I need to call out a certain surface finish value on my print that the machinist needs to hit. If the surface is rougher than this value, it may tear up the soft seal material and cause leaks or impede function. This is a standard surface finish call-out symbol. The most common way surface finish is reported is an average surface roughness, denoted as R sub A. This is the average distance between peaks and valleys of a surface from a baseline measurement point or datum. It can be reported in micrometers, which is usually shortened to microns, or it can be reported in micro inches. In the US, we use micro inches most commonly. The prefix micro means 1/1,000,000th. That means 1 micro inch is 1/1,000,000th of an inch. Divide an inch into 1,000,000 equal length parts. It's one of those. The polishing work I show here will maybe give us a 32 micro inch finish at best. For our non-American friends, that's a 0.8 micron finish or a number 6 finish. Let's start with the tools I use. I will link to places to buy all these or something similar. None of these are affiliate links. I'm not making any money off this or advertising any product. This is just what I bought with my money, and it's worked well for me and may be a good starting point for some of you. I use 400, 600, 1000 grit, and 2000 grit sandpaper. I have a selection of fine files of different shapes and sizes. These generally aren't used for polishing, but sometimes parts are so rough that you have to start with a file. I'll demonstrate this later in the video. I have a collection of stones from coarse to super fine. All of these are softer and require some sort of oil or honing solution. These are all fine, and they're a lot harder. They don't wear as easily. You don't really need to use lubrication with them. And then this one is super fine and very hard with really sharp corners. It's a ceramic stone equivalent to something like 3000 grit, I think. I'll show why these sharp corners are important later. I don't think Brownells offers this exact one anymore, but I will link to some that are similar. This stuff really isn't necessary, but it will save you a ton of time and effort. A Dremel tool with a polishing kit and a selection of polishing compounds. Sometimes I use these sanding drums or other grinding bits for profiling something before I polish it. I'll demonstrate some of that later in the video as well. If you didn't want to pony up the money for a Dremel setup, you could get some of this soft polishing cloth and like some of that Mother's brand like polishing compound. This stuff is too hard for use with this and has to be used with these. So you would need a polishing compound specific to use with this cloth. I have a selection of lapping compounds. This one is pretty coarse. I don't really use this much anymore, but this is some really nice diamond lapping compound. I have 1000 grit, 1500 grit, and 3000 grit. I really only use this for lapping in slides, which I'll show later in the video. General polishing considerations. Polishing can obviously be done for decorative or aesthetic purposes, but this video is really about polishing and cleaning up the contact interface between two components that slide or pivot with respect to one another to reduce friction. This guide should act as a jumping off point for you to start playing around with this and developing your own techniques and skills and finding which tools work best for you. There are many ways to do this, and I'm just sharing some of the ways that I do it. When we polish anything, we work from coarse to fine. We take off big projections and smooth out peaks and valleys and replace them with smaller and smaller projections, peaks and valleys as our polishing media or tool gets finer. We're essentially taking off the big scratches and turning them into smaller and smaller scratches until the surface is as smooth as we want. The best way to see where the firearm would benefit from component polishing is getting a couple hundred rounds through it, then strip it down and inspect every part. Where two parts interact, the factory coating will start wearing off and it will be a bit shiny. That's where you want to polish. Polishing inherently removes material. This will open up tolerances and clearances and can change the relationship between parts in your guns. Hopefully the parts have a decent surface finish to start with, so only polishing with a fine tool or media will be required, and it will remove minimal material. What about corrosion? We are, certainly exposing bare steel by polishing these components. Well, as I said, this polishing work is specific to parts that contact one another, where we should have oil anyways that will prevent corrosion. You don't need to refinish any of these areas if you properly lubricate your gun. Let's kind of start with the basics here, right? What if we just want to polish a flat surface? This is a mainspring housing. This is probably not something you would polish in general. So let's go ahead and start with sandpaper. This has a pretty decent surface finish on it. Maybe we'll start with 600 grit. You got to be careful with sandpaper. Sandpaper is very flexible, so it will tend to, wrap around corners a little bit as you're using it and take sharp corners off. If you're just using your finger up against a surface, you're going to be getting uneven pressure due to the squishiness of your finger. And so if you want to use sandpaper for a flat surface, what you're going to want to do is wrap it around something nice and flat and hard, like a file, just like that. So we'll go ahead and polish this little part of it right here with just sandpaper. You can see it's hitting some areas more than others, and that just may be because these were little high spots left after the machining of this part. But when you're doing this, you can see that the surface finish right here on the corner is a little bit different than the surface finish in the center. That means that I haven't completely gotten this surface to have the same finish of, this sandpaper. So I pretty much need to keep going until the surface finish is even across it, which means that I have evened out the smaller scratches that I'm leaving on the surface. So you can see there, it's almost all uniform except this little strip in the center. Another way you can do this is kind of just put it down on your workbench and hold it squarely on the piece of sandpaper and move your workpiece instead of the file. I prefer doing it the other way. Sandpaper may get clogged up with material and you need to switch it to a new piece. You can see that when they machined this, they left quite a low spot right here in the center of this flat surface. So it's taking a bit more work to get my surface to be even all the way across. Okay, so I'm going to go ahead and show you what can happen if you don't, put a flat, hard backer on your sandpaper, right? So we know that essentially I'm holding my sandpaper flat and it's still not hitting that center part of this surface, and that's because that center part of this surface is low, just, based on how they machined it or whatever. Okay, so let's just say I got my sandpaper on my thumb and I'm doing this on the surface. You can see I immediately started contacting that surface. That's because the sandpaper was allowed to flex on the soft pad of my finger down into that unevenness. So you can see that I have scratches all the way across that little low spot there now. Now we're going to go to 1000 grit, wrap this around my file nice and tight so I keep it flat. So now you can see, except for that little low spot in the middle, I've pretty much replaced all of my 600 grit scratches with the finer 1000 grit scratches. if this surface was even, that's already a pretty nice, shiny, low friction surface right there. But let's see what some 2000 grit does. Ooh, really shiny. So another thing is a lot of this sandpaper is wet or dry, and the benefit of getting the sandpaper wet is that you won't have so much of a buildup of junk in the sandpaper. The water will kind of carry the particles away and keep your sandpaper cleaner. So, you know, if you're dealing with something that's leaving a lot of junk in your sandpaper and clogging it up, just go ahead and get it wet. Okay, so that's pretty dang shiny. All right, what about polishing with stones? We'll do a little strip of this right here with some stones. This, again, like I said, has a pretty nice finish on it. So we're gonna start with 1000 grit stone. These are the softer ones that I need to use this solution on right here, this mineral oil honing solution. And we're just gonna start working her back and forth here. And you can see once again it's cutting a little bit unevenly, just to some waviness in the surface of the back of this part. You know, this stone's very soft. You got to use the fluid on it, and when the fluid starts drying off and getting used up, it'll start shaving away the stone like that. So you got to keep these softer stones really well lubricated if you want them to cut and maintain a good surface on them. You can put the fluid on your stone or on your workpiece. I'm making sure when I'm doing this that my stone is staying flat and parallel with respect to the surface. I don't want to be cutting like this or like this or like this or like this. That doesn't look too great. You can see that it's cutting more here and here and not really in the center because this surface apparently has kind of a bow to it. So, you know, if this started out as a flatter surface, this would be going a lot better for us. If you needed this surface to be really flat, this is maybe where you would start with a file, and you can go ahead and take this surface down until it's all the same height and then polish it from there. Now I have a nice little uniform strip all the way across, so that's what we're going to polish. Now, after I've used this stone and have a uniform finish of, you know, this surface roughness across it, I go to a finer stone. So you can see there's some really, really shiny spots now where I was using this finer stone, but the finer the stone or the sandpaper or the file that you're using, the less material it's going to be taking off. And so it's going to take longer and longer with each step to get all of the scratches of the previous step replaced with smaller scratches. So, you know, this is going to take for freaking ever. You can see the effect of using the finer stone where the really shiny spots have appeared. So now I'm going to use even a finer stone. Now, those smooth areas are really bright and shiny, but of course this is a pretty uneven finish at this point. You can see here, even holding that sandpaper around the file in an attempt to not knock off any sharp corners, you can see that I beveled these corners just a little bit. So these corners right here have stayed nice and sharp due to the flatness of these stones. So really, if you're trying to maintain an edge or maintain flatness as much as possible, you're gonna want to use stones. You can get polishing kits that come with all different shapes and sizes of these cotton buffing wheels. And then you get yourself, I have coarse, medium, and fine polishing compound, you know, kind of a hard material, but when you spin your polishing pad in there, it heats it up and kind of melts it onto this. And then once again, you put it on your workpiece, it heats up and melts. And then this has really, really tiny, tiny little abrasives in it that will polish the surface for you. And this polishing pad right here, this cotton one, is pretty soft. You know, this has a decent surface finish on it in the first place right here. So I'm going to start with medium. So you can kind of see the polishing compound melted there onto my polishing pad. Now we're going to go to our fine compound. Get a good coating of it on there. I like when they give me different colors so I know. So that's a pretty nice finish in a pretty short amount of time. That's why I like the Dremel and the polishing thing. You can still see some scratches. The scratches this way are generally going to come from their machining. Let's see what happens if we use this polishing compound on where we've already cleaned up with a stone or a file. So it definitely polished it and made it brighter, but it kind of even highlighted some of the scratches left over from the coarser sandpaper or the coarser stones and files. These all have really nice, pretty slick surface finishes at this point that would have really, you know, minimal friction. So like, what if you want to polish a trigger bow on a 1911, right? Because this slides inside the frame, so we definitely, you know, want to get a nice finish on this so it slides freely and makes our trigger feel even better. Well, damn, what I do with these, man, is I just hit them with the Dremel, you know? The other thing with this trigger bow is that if you round off these sharp edges on the top and bottom of the trigger bow, like, it doesn't matter, right? So, you know, I'll talk about being careful about, you know, taking sharp edges off and stuff when I talk about hammers and Sears, but like right here, man, it doesn't really matter, you know. Sandpaper wrapped around your thumb would be totally fine. I just, you know, will generally go ahead and hit them with the polishing pad here. I mean, you could use a stone on these too. That'd be totally fine. But again, it's, you know, going to take a long time, and you know, the soft buffing pad is going to conform to the irregularities in the surface. So, you know, it's going to get everything polished. Whereas with the stone, you're going to, you know, have to take time to knock down all the high spots first, and then you'll get an even polish across your surface. So you can see I just rubbed it there and it hit there. It hit back here. So stone's really not that great for this. You could just hit it with some sandpaper, and that's gonna do pretty good. And if you know, use it on your thumb, the softness of the pad of your thumb or finger will push the sandpaper down into all the little irregularities. You see I got pretty much most of that, and then you go to your finer sandpaper and do the same thing. You can get a pretty slick finish pretty quick, you know, but again, preferred method is still this guy right here for something like this. So let's talk about what I would consider a special case of a flat surface, right? This is a 1911 hammer with the hammer strut, and you know, a pin goes through it and it pivots in the frame of the pistol like this around the center pin. And so we want this surface and the other surface on the other side to be smooth so it doesn't have any resistance to pivoting in the frame. So on these, generally what I do is, like, I'm not gonna, you know, polish this whole surface. I'm just gonna run a fine stone across it and knock down all the high spots. So there's not really anything catching inside the frame where this thing pivots. It's, you know, pretty straightforward. You just make sure that you hold this surface really parallel to this surface and just kind of rub it all over. Now, this hammer is a bit gummy and shitty feeling as I'm doing this because it's covered in Cerakote, and you'll see the Cerakote kind of coming off as I do this. This is where maybe I'd give it a few swipes of a coarser stone first to kind of get the big chunks of that Cerakote off of there. Okay, that's looking good. And you can see, okay, the center of this is obviously low, and there's some high spots around this machined edge. Okay, that looks pretty good, right? So what I would do at this point is I would put this into the frame of the 1911, put the pin through it, and rotate it, make sure it feels good. Or you can even just slip this in the back of the frame like this and just kind of rub it around and make sure it's not catching on anything. So some of these things, it's like, this is how I would clean up the part. It's not necessarily polishing it or polishing this whole surface. That would be a waste of time. In the instance of this, I just want to make sure that it pivots freely within the frame of the gun, and to do that I just run a couple of stones over it to take off any high spots that may be catching as it rotates. So here's kind of another special case of a flat surface. This one's already polished, but this is a disconnector rail on a 1911 slide, and really, I don't care if I break this edge right here. I don't really care if I break this edge right here. And in some cases, I want to break the edge. This leading edge right here, I want to break because that's what pushes the disconnector down in and out of the frame. If this transition is smoother, it's going to make the action of the disconnector smoother. Another thing is this front face right here is what interacts with the disconnector as the slide comes forward. A lot of times these will just be chamfered out of the box and they will pretty abruptly hang up on the disconnector. It's a hallmark of a fucking cheap 1911. And so what I do with these is I take, if this is a chamfer, and I turn it into a smooth radius. The way I do that is if I can get a file in there, I kind of start taking swipes at it and adjusting the angle that I attack it with to make sure I get a nice smooth radius. Sometimes I'll get in there with stones. You're going to have to remove a bit of material, so you've got to get in there with a file and start taking swipes at it like this until you establish the general shape that you want. And then you can start smoothing it out with your stones, working from coarse to fine. And then again, it's pretty easy to just get in here once you've worked through up to your finer stones and get a final polish on it with this guy, just like this. Let's look at how I break this little edge leading into the disconnector pocket. I have a very specific stone that I like to use for this. It's this narrow triangular one, but this narrow edge right here is just about the width of that pocket. I wouldn't use a file on this. We don't really need to take much material off. We just barely want to radius it. So of course, I've already done it. I just start getting at it like this and kind of changing the angle of my tool to attack that sharp edge and start turning it into a radius instead of just a point. I'm also not removing much material, so it doesn't take very long to get just that little small radius on there that I want. Reach in there with my trusty polishing pad and go to town, you know? Let's take a look at the underside of this CZ P01 slide really quick. So I haven't polished this rail on it at all. It has kind of just a chamfer back here where this is the piece that hits the hammer and starts recocking it as the slide moves rearward. So what I want to do is I want to take this chamfer and kind of turn it more into a radius. And then I want to go ahead and polish this rail right here. It doesn't interact with a disconnector in the same way that the 1911 rail does, but just for demonstration purposes, I'm going to go ahead and polish it up. This file is just almost a bit too wide to fit down in there. This is sometimes where your small files come in. These are small enough to get down in here and not risk, hitting anything else in this slide. So this is kind of where I'll go ahead and just start breaking this edge a little bit and working it around with these smaller files. I need a new set of these soon. These wear out pretty quickly, but they also do cut both directions, which is kind of nice. Okay, looks a little bit more like a radius. It's kind of a smooth radius around that now. There's not really any sharp edges. And then right here on this rail, again, you know, you can see it's got some brass left from scraping over the top of cases, but it's generally the same finish as the slide. So I'm going to go ahead and kind of break this finish off with this a little bit and see what it looks like. Yeah, you can see it's kind of getting some of it. But really, like I said, you know, I'm all about efficiency. Go ahead and get after this with some coarse, then medium, then fine polishing compound, and I'll show you what that looks like. I mean, you can see how quickly that goes. And of course, I hit my little radius back here that I just established to get that polished as well. It does take a little bit of effort to get in here and clean off all that polishing goo after you've done this, but you know, you got to make sure you get it really clean so that doesn't gum up your gun at all. So that radius and that polishing I did right there is going to be really similar to the firing pin plate on a 1911 that already has a radius on it, and then I like to polish those right there as well. And I polish, you know, this rail on a 1911 and this radius on the firing pin plate the same way that I just did this. Kind of like I showed, I just kind of knocked down high spots on the surface of this hammer. For pinholes, usually I just want to knock down high spots in there and make sure they pivot freely on their pin, right? Just reduce friction. I don't need a, you know, super fine polish inside this pinhole. I also don't want to loosen up my pin to hole fit very much. So on pinholes like this, pretty much all I do is I roll up some 1000 grit or finer sandpaper, stick it through the hole, and give it a few twists and kind of work it back and forth a few times. You can kind of see on the sandpaper there some of the Cerakote coating is coming off from the inside of that hole. And what I'll do is I'll just, you know, stick my pin through there and make sure it rotates freely. And that's pretty much that on pins. This is a Sear pin. Again, same thing. I don't need to put a full polish on this thing. I just need to knock down high spots and make sure it rotates freely in the hole that it goes in. So a lot of times I'll just take sandpaper, fine sandpaper, 1000 grit, and just kind of do this, break up the finish and, you know, knock down any high spots and smooth it out. And then this is a Sear pin, so I would stick it through my Sear and, you know, rotate the Sear around it and make sure it rotates freely. On small pinholes and small pins like this, I pretty much only use fine sandpaper. Here's another place with a pinhole you may want to clean up so it pivots freely. You know, the beaver tail grip safety of a 1911, it pivots on the cross shaft of the thumb safety. Again, you don't want to loosen up that fit too much, but you can just do this a few times, knock down those high spots and get it pivoting a little bit nicer and smoother. And with stuff like this, like, I recommend taking it out of the gun, take your safety, put it in the hole, spin it around, and if it feels smooth, then you probably don't even need to do this, you know? Let's talk about a little bit larger pins or cylinders. This is a full-length guide rod from the Mac 9 DS. It had a Cerakote finish on it. You can see after shooting it a little bit, some of the finish came off. So polishing guide rods, I like to do that, and it's just because it'll reduce friction between the coil spring and then also the spring plug as they, you know, slide over this surface. There's one of two ways I do this. You know, I get my sandpaper. You can twist it like this. You can stroke it like this. But you know, that's pretty smooth. And then we'll hit it with some 1000 grit. And we'll hit it with some 2000 grit. That's pretty nice and slick, man. I mean, it really doesn't take much more than that. Pretty straightforward. If you did want to take it one step further, of course, our Dremel with the polishing pad and some polishing compound is a really good option here. So I'll demonstrate that on another part of this. Oh yeah, that's looking good. That is looking good. So another thing I'll mention here is that, you know, cylinders are not a place where you want to use a file or a stone. You don't want to use a file or a stone on pins either, because pretty much what'll happen is you'd have to come at the cylinder this way or something. But in any case, what's going to happen is you're going to make a facet, you're going to make a flat spot, and you're going to make a bunch of parallel flat spots in, you know, lines lengthwise on the cylinder. And that wouldn't be a huge deal for a guide rod because the spring and the spring plug slide this way, but on something like this where the Sear pivots this way on it, if you had a bunch of facets and say instead of a cylinder this was like an octagon or something, it wouldn't rotate very smoothly. So for pins and you know, cylinders like this, you really only want to use sandpaper or a polishing pad that can conform to the curves of the surface and maintain that smooth curved shape. One more thing I'll mention about this guide rod. So this is for a bushingless barrel, so it has a pinhole for taking down the recoil system. And sometimes run your fingernail across here, my little nub of a fingernail, and you can feel high spots and burrs around that hole. And you definitely want to take those off, right? Those will catch on the coils of the spring as they go past. So if this did have little burrs around it, this is actually where I would use a stone and just really carefully dress up the outside of this hole and make sure that I can't catch my finger on any high spots. And then I would go ahead and polish it. And when I'm rubbing my stone across it, I can feel it catching on those burrs and those high spots. Like when I do it here, smooth, smooth, there it gets a little bit rough, smooth, smooth, gets a little bit rough. So I know I kind of got a burr right here at this angle. So I'll go ahead and just work that. And you know, they're generally going to be small, so you can take them off with a fine stone pretty quickly. Or sometimes, you know, just polishing it or rubbing your sandpaper over the surface will take those burrs off as well. Let's talk about kind of a special case of a pinhole, if you will, and that's like a barrel bushing, right? So there's going to be larger diameter holes, And pretty much if you have a high-end gun with a nicely fit barrel bushing, like, you don't need to polish it, man. It's already, got a pretty nice finish on it. It's going to have tight clearances that you don't really want to open up anymore. But, let's say you buy a cheap 1911 and you got, 5-6 thousandths of clearance in there anyways, and it's just like a pretty, rough finish in here, then yeah, if you open it up another half a thou, what's the big deal? I have, machined barrel bushings for a really nice tight fit, and I'll undersize the bore by about half a thousandth, and then I will, go ahead and polish them to my final diametrical clearance that I want, and get that last half a thou by polishing. And I just do that on the lathe, right? And then that way, I know that I'll be keeping the surface uniform and concentric as possible by spinning it on the lathe to polish it. If you got a higher end gun with a nice fit barrel bushing that's already got a nice finish in it, I wouldn't polish it. But if you have a cheaper gun that has kind of a so-so finish on the inside of the barrel bushing, and it's, has quite a bit of clearance anyways, then it may feel nicer if you polish it. So I'll go ahead and show you how to do that. There's two ways I like to do this. Wrap your sandpaper around something circular. You could wrap it around your guide rod. You could wrap it around your circular stone. I have some of these little like nylon rods for drifting sights and stuff like that work really good. So, let's say we already got a pretty good finish in there. So we're going to start with 1000 grit, and I just wrap it up like that, and then work it around and try to hit, all parts of the surface evenly. So I'm not, making an egg shape or something like that. I mean, you should be doing this with really fine sandpaper and not removing much material anyways, but try to keep it as uniform and even as possible. The other way to do it, of course, is just this. It's so quick, man, and like that's it right there, I like to profile and polish the tips of my hammer struts. Usually they're kind of squared off and have sharp edges that can dig into the cup that goes on top of the mainspring, and that again creates excess friction. So what I like to do is profile them first, and there's a few different ways to do this. I've already, profiled and polished this one, but I'll do the process over for demonstration purposes. So profiling it, you can take a file and start breaking the sharp edges and work your way around and kind of make it a shape like this, kind of a hemisphere that's nice and smooth. So doing it with a file will take quite a long damn time. A lot of times these hammer struts are hardened. Once again, we're going to come in with the Dremel tool. I got a bunch of these little sanding drums. These are nice. Or, you can use something like this, like a little grinding stone. But I just take this and, really, really carefully, grind the tip of it into the shape that I want. When I have the profile I want, we're going to polish it with sandpaper or a polishing drum on the Dremel. So again, after I hit it with a sanding drum or a file, it's going to be pretty rough. So I'll generally start with 400 or 600 grit, kind of wrap the paper around it, squish it around it with your thumb behind the sandpaper and stuff, because you want it to conform to that surface that you just cut. I can still see some of the coarser scratches from my grinding, so I'm going to keep going until I get a nice uniform surface of 600 grit scratches. It's looking pretty good. Go to my 1000 grit. $2,000 grit. That's looking pretty good. It's pretty shiny. Quicker, easier way to do it, get a better finish, obviously the Dremel tool. Oh, beauty, look at that. It's going to be a nice low friction tip right there, man. I like to polish the ends of my mainsprings. As mainsprings compress, this surface and this surface will rotate a little bit with respect to one another. And what happens is that rotation causes friction, either, you know, up against the mainspring plunger or the underside of the hammer strut or whatever it's contacting. And so I like to, you know, it's really nitpicky, don't get me wrong, but I just, you know, like to polish these. And sometimes there's some sharp edges and burrs left on the closed end of the spring right here, so I take care of those too. Just kind of dress them up with a fine file really quick. Pretty easy to tell when you have the burrs gone with your fingernail. You can feel them. I think this is actually the first thing in this video I'm going to polish that I'm actually going to fucking use. Like, this is going to go in a Kimber 1911 that I have pretty soon. I'm going to redo a trigger job on it. So once I break any sharp edges like that, then again, ununiform surface, man. We get after it with sandpaper. You can see I've taken off the finish there already. It's a little bit brighter and not so kind of brown colored. And really the finish that we're worried about is only on the top surface of this that is, you know, going to be parallel to another surface like this. We don't really need to get around the sides of the coils or down in there really at all, right? 1000 grit. $2,000 grit. That is pretty freaking shiny, man. Check for sharp edges on this other side, and I can feel it where that coil's cut, so I'm gonna dress that up really fast. We're gonna start with coarse on this one. Yep, much quicker and arguably better results than the sandpaper. Sometimes these can be a little bit hard to clean off because the polishing compound melts and then resolidifies down between the coils, but you know, you can just kind of slip your paper towel in there and get it kind of pushed out. So those are some nicely polished mainspring ends right there. So this is the barrel for my HKP30. You can see this is the factory finish. It looks pretty nice. I haven't done anything to this barrel yet, but let's say I want to polish that up, right? And here is the feed ramp, again, untouched from the factory for my CZ P10F. And you can see that that's just got the nitride finish of the barrel on it. We got sandpaper and we got our Dremel tool. Again, you know, since this is a cylinder, I'm going to go ahead and wrap my sandpaper around the cylinder that fits in there. And it works really good. Works really, really good. I'll link to these nylon rods in the description as well. They're a really handy thing to have. Cheap too, so. And I'm, you know, holding this rod, you know, parallel to the surface, not tilting it this way or this way. One thing I will do is right up here at the throat of the chamber, sometimes I'll tilt it just in there just a little bit to kind of smooth that edge out for the cartridge casing to crest over as it's being loaded. You know, I wouldn't start any more coarse than 600 grit. Wrap our 1000 grit around there. Same thing. You can kind of see here I'm leaving a little bit of nitride out on the corner here and out on the corner here, and I'm not super concerned about that really. I mean, you know, where's the bullet front and the cartridge case going to be mainly riding kind of in the center there, but you can kind of tilt this side to side to match the flare of this to get that nitride polished off there and get a full polish on your feed ramp. So it's looking pretty good. We'll go to our 2000 grit. Man, I mean, you know, that goes pretty fast. I've been at this all of 4 minutes. So that's a pretty decent finish on that little barrel ramp right there. Let's just, you know, obviously go ahead. We're going to do the Dremel, stick on a new polishing pad, and use fine buffing compound for this one because this already kind of has a bit of a polish on it. I mean, that's so quick. Look at that, 15 seconds, 10 seconds. I'm gonna go ahead and touch this one up too. Some Q-tips to get all the shit out of the little corners and get all that polishing compound off of there. And push a couple of swabs through the barrel. And I'll put a little bit of oil on that feed ramp, and I'll send an oily swab through the bore as well while I'm at it. You know, both these guns fed fine. I have had no feeding issues with these pistols, with any type of ammo, so this was completely unnecessary. I was just doing it for demonstrative purposes. But, you know, polishing your feed ramps can sometimes help alleviate feeding issues. Maybe it will help in conjunction with some other tweaks and changes to the firearm. So, you know, polish feed ramps at your discretion. We took the nitride finish off, and nitride adds hardness to a surface. And this is a nitride coated barrel, but the feed ramp was uncoated before we started. And you may say, well, now we're, you know, losing our hardness on a wear surface, right? Well, this steel is still going to be much harder than any brass case or copper jacketed bullet. I don't think most of us are running steel case anymore, kind of after the Russian imports dried up. I'm not worried about the hardness of this feed ramp. And, you know, clearly HK wasn't from the factory either by giving us a semi-polished feed ramp that had no nitride on it. This is an AK trigger group. I'm pretty sure they manufacture these by letting a pack of dogs chew on them. These things are incredibly fucking rough. AK triggers kind of suck, but you would be surprised how nice they can feel if you polish them. But these surfaces are so rough that it would take forever if we started with a stone. So this is the rare case where you will start with a file sometimes. This trigger hook catches the hammer just like that. So, you know, we'd want to polish the underside of this, and we want to polish this. I'll go ahead and polish this face right here because it'll be easiest to show. And there's so much contact area here that we're not quite as worried about knocking sharp edges off, right? We're not dealing with like a 1911 Sear that has 20 thousandths wide Sear face, right? We're dealing with fucking 1/4 inch of engagement here or whatever. So, We still want to maintain this geometry and keep it flat because that's going to give us the smoothest feel for the trigger. You can see the scratches. I mean, you can see how rough that finishes when I start taking off the high spots there. So with this more intensive file work, I showed a little bit of file work previously in the video, but I'll give you some general, basics about using your file. If you're trying to maintain a flat surface, obviously you want to keep it as flat to your surface as possible. You don't want to do this. You don't want to do this. You don't want to do that. You don't want to do that. And generally, files will only cut in one direction, and that's away from the handle. I did show you some smaller needle files I had that cut both directions, but this only cuts one direction. So you're going to want to take your swipe, pick it up, move it back, take another swipe, pick it up, move it back, take another swipe, right? If you run this file back this way across your surface, it's going to dull your file really badly. The other thing you want to be mindful of on files is sometimes they'll have cutting teeth on these edges, sometimes they won't. If you're trying to dress up this surface right here, but it has cutting teeth on this side, you're going to be gouging this surface up. Maybe it doesn't matter, maybe it does, something to be aware of. So I'm going to call that good for now. We didn't quite get the surface uniform all the way out to the edge. So now that we have that, we're going to go ahead and either polish that with a flat stone to keep the surface nice and flat. This is where after that file, I'd actually probably need to start with a coarser stone than this even. Another thing you could do is you could wrap some sandpaper around your file and go after it that way. It may bevel the edges a little bit, but since we have so much, contact area with the trigger hook, I'm not worried about blending this corner off a little bit. You can already see it's got a pretty good sized radius on it. Sandpaper might be working the best for this until I get down to a smoother surface finish. Use a bigger piece of sandpaper. Pro tip. AKs are pretty crude weapons, and their trigger groups are pretty crude trigger groups, so you can treat them pretty crudely, and that's what you are seeing me doing right now. At this point, I got that evened out, pretty well, and we're just gonna get after it with the old Dremel, man. Oh yeah, that's looking good. Where the bolt rubs back over the hammer as it resets it. Well, actually, I'll show you, man. Sometimes, if it's a place where a hammer hook interacts, I'm going to try to make it a little bit smoother before I polish it, but you'd be surprised what this will look like if you polish it starting with coarse polishing compound. I wouldn't really actually bother going to the fine compound on this. That's not bad, right? That's gonna make a big difference in the amount of friction between the, the bolt and the hammer as the fucking action cycles. I mean, it's fucking take your gun apart, see where shit's shiny, and make it more shiny, man. Let's start with what firearms are good candidates for slide lapping. Cheaper 1911s, aluminum and steel frame pistols with more frame rail contact. Generally, polymer frame and striker fired pistols with these little frame rail inserts here won't benefit much from slide lapping. I've tried it before and I couldn't tell a difference. So your Glocks, your M&Ps, whatever. I'm going to show you how I lap in a slide on this CZP01. This has an aluminum frame with internal rails and lots of rail contact area, but not super tight tolerances. Higher end guns, Wilson Combat, Nighthawk, Staccato, Atlas, they're all going to have a really good slide to frame fit, high quality machining and finishing that will result in a very smooth surface already. Slide lapping will inherently open up clearances a little bit. I use very fine slide lapping compound, like 1,000, 1,500, and like 3,000 grit equivalent diamond lapping compound. And I wouldn't expect that it would open up clearances more than half a thousandth or so. And so, on a loose slide to frame fit, not a huge deal. But if you get into a higher end gun with 1 or 2,000 slide to frame clearance, then, half a thou is 25 to 50% of that. Before jumping into lapping this slide in, I will mention that lapping the slide in is not necessarily going to polish the frame rails. It's really just going to be knocking down high spots, evening out the finish that's already there. It's more like what I did with the side of this hammer. Don't expect to see necessarily a mirror finish on any of the components, but it should absolutely be smoother. I did lap the slide in on this pistol when I first bought it with this 600 grit lapping compound. I don't use this stuff anymore. I think it's too coarse. Now that I have finer, nicer lapping compounds, I'm going to go ahead and lap this in. Skip the 1,000 grit because I do have quite a bit of rounds through this pistol, and I already did lap it in with this coarser stuff, so it's pretty smooth already. But I'm going to hit it with the 1,500, then the 3,000 grit. Aluminum frame, steel slide, internal rails with lots of contact area, but not super tight tolerances between the slide and the frame. So I think this is a good candidate for slide lapping. You can see the rails have some shiny spots and some spots still with coating on them. So the way I do this, I will take the barrel and recoil assembly out of the slide. Generally, I do this when I have other parts out of it and the frame completely stripped down so it wouldn't have the hammer. It doesn't really matter. You can do it with the hammer in there. Clear our slide rails out. Make sure they're nice and clean. You start with coarse, work to fine. So I am going to start with 1,500 grit on this, and pretty much just going to squeeze some out on the rails. Take a clean Q-tip and kind of distribute it around to get it where I want it. And the amount I dispensed, I mean, this is a lot of rail area, and the amount I dispensed is like good enough for both sides pretty much. So just kind of get it everywhere. And of course, as soon as it starts sliding in the rails, it will figure out where it needs to go and get there. I'm trying to stroke it through the full range of its motion, but I'm also not, putting force or pressure on it really. I'm just sliding it back and forth. I don't want to push down on it. I don't want to pull up on it. I don't want to push it down this way. I don't want to push it up this way. I just kind of want it to, slide in there the way it would if it was reciprocating. I don't need to put any more pressure on it one way or the other, because that will, kind of open up clearances and stuff like that more than we want. That's about as much as I'll do with a particular grit. What was that, maybe 30 seconds total of rubbing her back and forth there. And so you do want to clean it, pretty well between each grit, because you want only the next finer grit on there for your next step. You don't want any residual of the coarser grit material. Final, 3000 grit lapping compound. So that's it. That is lapping in a slide. And I'm gonna clean all this off really good and give her a coat of oil and reassemble it. Hammers and Sears. This is outside the realm of what I would consider simple and general polishing procedures. It can easily result in an unsafe condition with your firearm if you do it wrong. It's really easy to knock off a sharp edge on a Sear or a hammer hook. This also clearly gets into the trigger snob realm and the point of diminishing returns for your time and labor. I wanted to throw it in with this video for completeness, but only do this if you have lots of practice and experience. Always safety and function check your firearms after modifying any ignition components. If you want to build these skills so you can work up to polishing things like this and get every little bit of performance out of your triggers and firearms, then, practice on extra or used parts first. Let's start with some Sears. So here I have the factory Sear from my Shadow 2. This is a Sear from a CZP09 with the Omega trigger system. This is, of course, a 1911 Sear. So this Sear is pretty much untouched. I think I only fired maybe 100 rounds through the pistol with this Sear installed before I swapped it out. So let's take a look at what I would do to clean up this Sear. Tools used for ignition components. Fine grit sandpaper. This is only for cleaning up the pinholes. Really fine, hard stone with a nice, smooth, flat finish and very, very sharp edges on it. Magnifying glass headset. This is also a very, very handy tool for this kind of delicate, detailed work. Let's start with the easy stuff on this Sear. This pivots in the frame of the pistol, and it has stuff here and it has stuff here. I want to minimize the friction and resistance to pivoting, so I'm going to clean up this face, and I'm going to clean up this face. This is a nitride part, so I'm only going to use my very finest stone on it. If this was a Cerakote covered part, like this cheap Sear was from my Mac 9 DS, that's where I would probably start with this slightly coarser stone. But on this one, we're just going to go ahead and use the really, really fine ceramic stone. Keep the face of this as parallel as you can to the surface of the stone. It doesn't take much, and you're going to start exposing the high spots around the machine edges and the pinhole. So that's about all it takes to knock down the high spots on the face of a Sear or a hammer. Again, do that on the other side. I'm not putting much pressure on this at all. I like working the stone across it. It gives me a better feel for what's going on the surface there, but you can certainly put this down on your stone. Do it this way. That works great too. As long as you keep the surface right here flat up against this surface and don't tilt it or do anything like this with it. And again, I'm not really pushing down hard at all. I'm kind of just gliding it across the surface. That's about all I'll do. It's about all that's needed. Now I do want to go ahead and clean up this pinhole. What I would do is I would take the pin and rotate it in here like this, I can actually feel one little spot where it catches. So, a little bit of 1000 grit or finer. That's about all it takes. Put this back in. That feels better. That one little spot that I felt's gone. It doesn't take much. And then I will go ahead and, you know, hit the pin that it pivots on just a little bit. Feels really nice. Didn't loosen it up. This little surface right here is what hooks the hammer and holds it to the rear, just like this on the hammer hook. And then when you pull the trigger bar actuates the sear, pivots it up out of the way, and the hammer falls. You can also see that the hammer hook engagement is probably slightly less than half of that sear face. It's critical to maintain sharp edges on these. You don't want to round this bottom edge off. There's an exception to that with 1911 Sears. We're not talking about cutting new sear faces here. That's way outside the realm of what I want this video to encompass and what it should encompass, especially if you're new to polishing. So what we're simply talking about is polishing this face right here where it interacts with the hammer hooks to make the release of the hammer smoother. It'll make your trigger feel nicer. It'll make it feel crisper. Probably not by much, fair warning. But if you're trying to extract maximum performance out of a trigger system or a trigger job, there's a little bit of performance to be had by polishing the interface between the sear and the hammer. How you polish these surfaces: you only use a very, very fine, hard, flat stone. And it's difficult too, because it's hard to feel if the stone is parallel to the surface or not, right? If it's slightly like this or like this from the surface, you may not feel it. And this is a very narrow surface, so it's very easy to have your stone do this. So this is where you have to practice. You have to practice feeling what the stone is doing. You have to practice feeling that you're polishing across the whole face and not just taking off a corner or an edge. You have to keep the stone flat to the face this way. You have to keep the stone flat to the face this way. And you have to maintain that through every single stroke of the stone across that surface. So I'll show you how I polish this. You can see this is just a nitride finish on this sear face. I'm going very slow. I'm barely putting any pressure on it. You can kind of rock your stone back and forth on the face of it here and feel like, no, there's a corner. Oh, there it's flat. Nope, there's rocking over the other corner. So there it is right there. And then maintaining that angle for every single stroke that you do. Check it very often. Okay, see? Yep, I can tell that I'm square on that surface because I'm starting to take down that finish pretty evenly across that face. So again, I put it on there. I don't move it. I kind of feel, oh, there's my face right there. And check it a lot too. You got to use a really fine stone on this and check it often so you don't get carried away and pull it off your stone and go, oh, shit, got to buy a new sear, you know? You'll feel it too if you're off this way or this way. You'll feel it catch on this end right here. So you can still see across this face that there's little traces of the nitride finish. It's getting pretty well polished, but there's still little slight darker spots. So that could just be unevenness of the material on that face. It could be unevenness of the coating on that face. You can see that I'm going long ways across the face, right? I'm much more likely to knock a sharp corner off if I'm making my strokes like this across the short face. I don't like to do it like this. It's quite a bit harder for me to feel if I'm keeping the sear face square to my stone. I don't want to I don't like putting this in a vise or anything and trying to do it that way. Again, it's pretty critical for me to be able to hold both these pieces in my hands and feel when I'm rubbing my stone flat across that face and not catching on any corners. It kind of gets easier to feel the surface once you start polishing it, because you're taking off high spots as well, so you're giving yourself a flatter spot, a flatter reference point, and then also it's going to be smoother than all of the edges in the surrounding metal. So if you're slightly off that surface, the difference in the feel of the friction of the stone sliding is quite obvious. Got to listen carefully too. You can hear it. This top edge right here doesn't contact the hammer at all, so I actually don't care if I round this off. So I'll demonstrate. You can hear it. Listen really carefully. So this is on the face. Here's on the corner. It's quite a bit different sounding, and it feels different as well. So that's looking pretty good. That's pretty well polished. I'm getting tired of doing this. I'm not going to use this fucking sear anyways. You can see there's still maybe a little spot of nitride right there. Very, very thin, but generally, I mean, that's a really nice polished surface on that sear. Let's look at another sear. This is the sear from my CZP09 with the Omega trigger system, and you can see how much wider that sear face is. It's almost twice what the Shadow 2 sear face is. So sears like this, really easy to clean up because it's super obvious when your stone is flat up against that surface. Really easy to feel it. You can see that the whole sear surface here is not very uniform because I still got a big blotch of nitride there. So that means that's a low spot. But with the hammer hooks only come a very short way up onto that surface. This is not the correct hammer. That's for a Shadow 2. The hammer's still in here, but you get the point, right? The hammer hooks don't come up all the way to this little blotch of nitride, so I don't care if I get that completely removed. Where the hammer hooks contact is nice and smooth and polished. Let's go ahead and look at a 1911 sear, which is probably what a lot of you want to figure out how to polish. These have quite a small sear surface. You polish it in exactly the same way as I showed with these two sears. You just have to be really, really careful. I only polish sears with a jig now because when I get a 1911, I cut new primary and secondary angles on the sear to reduce trigger creep. This is a jig from Brownells. It's adjustable for the angle of your primary face, and I have it set exactly where I want it. So you put the sear in with your pin, and then you adjust that set screw to change the angle of the tip of the sear. You run your stone back and forth across the surface, and that's how you cut the sear angle differently with, a little bit coarser of a stone. And then I polish that same surface that I just cut with a finer stone in the same exact manner. Hammers, the other part of the ignition component equation. So I'm going to start with this 1911 hammer, and this is where you only do this with very fine, very flat stone with very sharp, crisp edges on it. Let's understand why it's so critical to have a stone with sharp edges for this. So I've drawn a hammer hook for a 1911 here, and the hammer hooks are generally going to be 18 to 25 thousandths tall. There's not a lot of height there. You have to have a very sharp edge on your stone to make sure you get an even cut all the way across your face. Let's say you even have a little radius on it like this. That's going to result in a hammer hook profile like this. This is very unsafe. Let's say you have a really big radius on your stone. When you get done, your hammer hooks might look like this. This is also really unsafe. Good, hard ceramic stones are a bit expensive. This was probably $35 for this one stone, maybe 40. They're also very hard and very brittle. You need to keep these in their own little protective tube at all times. Unless you're using them, you let this thing roll around in your toolbox and do a meet and greet with your other tools. These edges are going to get damaged and broken off. So 1911 hammers are pretty straightforward because the relationship between the hammer hook face and this surface right here is 90 degrees. So if you have a 90-degree stone, you put it right in there, rest it across this face, put it up against the bottom of both hammer hooks. You don't want to be doing this. You don't want to be doing this. You don't want to be doing this. And you don't want to be doing this. The stone stays parallel to this surface, and the other side of it right here stays parallel to your two hammer hooks. And again, very gentle, very little pressure. Listen and feel and make sure you're contacting both hammer hooks evenly as you're doing this. The hammer hooks on this have already been cut down and polished. This was the hammer in my Mac 9 DS. I replaced it because it has this stupid little undercut right here underneath the hammer hooks that my Sear was falling into, creating excess hook engagement and tons of trigger creep. That's why I replaced it. Anyways, this is it. This is how you do hammer hooks on a 1911. Nice and easy. Make sure your stone doesn't start rolling away. You have this really nice surface to index off of right here. That's what you use. Yeah, that's it. That's the finish you're looking for. You're looking for a nice, uniform, shiny finish across the hammer hooks, just like that. For shits and giggles, put some Sharpie on them. Okay, nice and black all the way across. There, you can see I just took all that Sharpie off evenly across those two hammer hooks. Let's take a look at this CZ Shadow 2 hammer. I have a Cajun Gunworks hammer in my Shadow 2. This is the factory hammer. Here's your safety catch. Here's your actual hammer hooks right here. If you look very carefully, that this face of the hammer hooks is not perpendicular to this face. So if you index the face of your hammer off of this, you are not going to be contacting those hammer hooks at a plumb flat angle. So you always have to look at your hammer hooks and see, okay, do I have an index point to put my stone on? And if I do, is it the same angle as the faces of my stone? You know, usually 90 degrees. In the case of this Shadow 2 hammer, it's not. You can polish these hooks. It's a pain in the ass. I really would recommend against this unless you have done this a lot. But I will show you, they can be polished. You gotta feel, you go, no, okay, I can feel it's digging into the corner there. It's right about there. Okay, I think I'm hitting the face the way that I should. You can kind of, get your magnifying headset on and look at it from this direction and kind of tilt your stone around and see when it's flush. I can see I'm hitting that face nicely. You can see that I'm not taking off that sharp corner on the top of the hooks. The other thing I'll do is, as I'm doing this, since my stone's a little wobbly this way, I take my thumb and my finger and I press it into the corner of my stone and kind of help my other hand hold it in the same angle through every stroke. But that's it right there. That's all it took. I got those hammer hooks polished. I did not knock off my nice sharp edge. They're polished all the way across the face, and you probably wouldn't even be able to tell the fucking difference. After you do any sear to hammer interface work, you want to make sure your hammer catches on the half cock or the safety notch. You want to make sure that it catches on the full cock notch, and then you want to fucking yard on that thing and make sure that you cannot knock it off of that sear. Another thing you can do with hammer fired pistols is give it a really nice shock, and if you have weak hammer to sear engagement, it'll knock the hammer off if you do this. It's not very kind to do to the gun, but your safety is more important. Okay, so what about the ignition components in a striker fired gun? Yeah, you can fucking polish them, okay? So this face right here is what, in the case of a Glock, the trigger bar grabs on. So you can absolutely take your stone very carefully and dress up that surface right there and polish it. Same thing, you gotta do it with a fine stone. You gotta do it very carefully. You don't want to round this sharp edge off. You don't want to change the angle of this face, but you can do it. I've done it. And I'm telling you right now, it's probably a waste of your time. You can take this trigger bar out in this rear vertical face right here that grabs the little striker. You can polish that. Again, probably a waste of your time. There may be more benefit to be had from fully pre-cocked striker fired triggers like the M&P that actually, has a sear that pivots and has a larger contact face than just some little shitty stamped piece of metal. Walther PDP, Canucks come to mind in terms of their fully pre-cocked striker systems where they actually have sears. Again, I've done it on M&Ps, fully pre-cocked striker systems. I don't think it's worth the time. Your mileage may vary. Do whatever sparks joy for you, my dude. You can pretty much polish any metal, brass, aluminum, bronze, copper, but the metals we will be polishing inside the action of a firearm will be steel or stainless steel with various finishes. This was bare, uncoated stainless steel. This was bare, uncoated stainless steel. This is carbon steel with a phosphate or like parkerization type of coating on it. This is carbon steel with a Cerakote finish. This, barrel feed ramp right here was steel with a nitride finish. This barrel bushing is carbon steel with a nitride finish. Nitride and phosphate or parkerization on top of steel, those polish up pretty much the same. The coating is generally pretty thin, comes off pretty easily. I really do not like Cerakote. I don't believe it belongs on the inside of a gun. On parts like this hammer is finished with Cerakote, and It makes everything harder to clean up. It's gummy, it's sticky, it loads up your file, it loads up your sandpaper or your stone. It's excessively thick. The thickness of it is generally very uneven. So Cerakote covered parts are generally going to take a little bit more to clean up. You don't want to polish electroless coatings, like if it has nickel boron on it, if it has nickel PTFE or what's called NP3. This is a NP3 coated striker. You don't want to polish those because that's pretty nice low friction finish, and it has a little bit of lubricity properties. So you want to leave that on there. Sometimes, like trigger shoes in a 1911 will be polymer. You can polish plastic. You can. The harder the plastic, the easier it is to polish. But I don't really find that there's any point to polishing a trigger shoe like this because it has such a low coefficient of friction with respect to an aluminum or a steel frame that it may be sliding in. One thing to look out for on these is look for any sharp edges or burrs or mold flashing from the manufacturing process, and just quickly take those off with some sandpaper, a file, or a razor blade, and call it good. This video took a while to make. It was difficult to choose what information and demonstrations to include and how to organize it. I still feel like it's a bit long, rambling, and disjointed. There are so many details and techniques related to polishing. I hope I gave you enough information and background to get a good start on this. I hope all the timestamps I provided will make it easy to come back and reference it if you're working on projects in the future. There's much more performance to be gained with cheaper guns, specifically ones with steel and aluminum frames that have more slide to frame contact area and slightly looser tolerances. A cheap 1911 is a really good place to start learning this stuff. Polishing one component likely won't make a difference. Polishing a system of components likely will. In my experience, most striker-fired pistols don't have much performance to be gained from polishing. More expensive guns with higher quality machining, finishes, fitting, and tuning won't need polished at all. Stay safe, wear your safety glasses. When in doubt, go slower and start finer than you think you need to. It's hard to put material back on. Practice on parts you don't care about. Function and safety check your firearms anytime you do any work or modifications to them. Properly lubricate your gun. If you think you may have fucked something up and your gun's unsafe now, don't shoot it. Worst case scenario is you probably just need to replace a part. Go ahead and treat yourself to a Dremel tool and a polishing kit. You deserve it. I've mentioned in many videos, I'm not a professional gunsmith. This is all self-taught and learned through trial and error. I'm not the authority on this, and I'm only showing the techniques and tools I use. I still screw up parts. It's not a big deal. It comes with the territory. It's frustrating and sometimes expensive. Recently, I overfit a grip safety to that TSOS 1911 carry DS I was working on. It made it so the grip safety disengaged if you just barely touched it, which is unsafe. So I had to throw out a brand new Ed Brown grip safety that cost me 85 or 90 bucks. Let me know if there's anything I missed. Leave any outstanding questions in the comments down below. Share your tips and tricks for polishing in the comments. It may help out others or teach me something. As always, thanks so much for watching. I'll catch you next time.